Hi and Assalamualaikum. Today we present on the Harmonics impact on power system protection. Okay, so we are from group 11. Okay, we are consist of 5 members, which is the first one is SHAHRUL NIZAM bin SABRIE, DE 2098. The second one is me, Aiman Fatina binti MUHAMAD KAMAL, DE 2094. The third one is NADZIRAH SYAZWANI bin MOHAMAD FAUZI, DE 2011-3. Okay, the fourth one is NURIN HUSNI bin AZEMI, DE 2098. And the last one is MOHAMAD Aiman SYAZWAN bin MOHAMAD JAFFRI, CE 2063. For the introduction, power system from the backbone of modern society, facilitating the distribution and transmission of electrical energy to meet various residential, commercial, and industrial needs. These systems are characterized by their complexity, involve a network of components such as power generation, transmission line, transformer, and load centers. Ensuring the reliability and uninterrupted operation of power system is one of the crucial thing that power engineering needs to face. So one key aspect of power system operation is the phenomenon of electrical harmonic. Harmonic voltage or current waveform that operates at frequency which are integer multiple of the fundamental power frequency can disrupt and standard sinusoidal power waveform and cause multiple problems. This issue can range from efficiency losses and potential equipment damage to creating difficulty for the proper operation of protective devices. Okay, power system protection scheme is one of the important protection in the power system, okay, that can protect the effect from the fault and abnormalities, including those induced by harmonic. Okay, this report is aimed to understand and evaluating the impact of harmonics on this power system protection scheme. Okay, that's all. Next, my friend will continue. Thank you.
Assalamualaikum, my name is NADZIRAH SYAZWANI, binti MUHAMAD FAUZI, DE 200113, and I will continue with the literature review. Harmonic sinusoidal voltage or current have a frequency that are whole multiples of the frequency at which the system is designed to operate. Harmonic frequency are multiples integer of the fundamental frequency of the waveform. For example, if the fundamental frequency is 50 Hz, the second, third, fourth, and fifth harmonic component will be at 100, 150, 200, 250 Hz respectively. Harmonic have a significant impact on causing harm to protection device, electrical device, transmission line, equipment, as well as the short life electrical equipment. Harmonic cause unnecessary disturbance to the source voltage, source current, and other system component, in addition to increasing system losses. Within the power system, voltage and current harmonic mainly have the following effects. The principle of application of harmonic level resulting from series and parallel resonance, degradation of the power factor, overheating of the phase. Within the power system, voltage and current harmonics mainly have the following effects. First, the possibility of the amplification of harmonic level resulting from series and parallel resonance, degradation of the power factor, overheating of the phase and neutral conductors, efficiency of the generator is reduced day by day due to harmonic. Eddy current and hysteresis losses in transformer, overheating of the system component such as generator, motor, and transformer, flowing of additional current through power capacitor, decrement in the useful life of the induction lamp. Harmonics can corrupt deteriorate. Harmonics can corrupt or deteriorate the working practice of the protection relay used in the power system protection. When harmonic distortion is present, digital relay and algorithm on sample or 0% are especially vulnerable to inaccuracy. Harmonics occur in two conditions in power system protection, which is first condition is during the fault condition and non-fault condition. The effect of fault in this harmonics include fault stripping, coordination, and sensitivity issues, equipment breakdown, difficulties in locating the source of the fault, resonance issues, and overheating issues. Unless they generate significant distortion, non-fault harmonic generators have less of an influence on power system protection device, even though they may still need attention and mitigation. As we can see here, figure 1 is showing the sinusoidal waveform for 50 Hz with third, fifth, and seventh harmonics. So we can see this one is the ideal waveform, which is the original waveform, and third, fourth, and fifth waveform is as we can see here, the differences between the amplitude and the period for each cycle to complete it. So in figure 2, it shows the sinusoidal waveform for 50 Hz, which distorted by the third, fifth and seventh harmonic. As you can see, the differences, the ideal waveform and the distorted waveform. You can see the difference between the amplitude waveform itself.
Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad SYAZWAN bin Muhammad JAFFRI, package number CE200063. Okay, we continue the presentation with the methodology. Methodology, it contains 7 parts. Okay, the first part is theoretical analysis. So, a harmonic is a non-integer multiples of a power system fundamental frequency. The source is nonlinear load like power converters, motors, and arc furnace. The impact of the harmonic is a harmful effect on power system, including higher loss, overheating, voltage distortion, impedance error, and protection malfunction. So, the protection strategies is compare current and voltage waveform to preset threshold and isolate faulty component. The mitigation technique is harmonic filters, power factor correction, load balancing, and harmonic insensitive protection method. So the theoretical investigation we got is analyze harmonic impacts through Fourier analysis or simulation tools. The goal is to improve in protection method and reduce the influence of harmonics on power system. Next, the simulation tool. Okay, simulation tool is a software program for modeling power system behavior. The purpose is to investigate harmonics effects on power system protection strategies. For example, we can use MATLAB, Simulink, PSCAD, EMTP, and RTDS. The advantage is it can evaluate various mitigation approaches in a controlled environment. Next is improve understanding of power system behavior and identify potential issue. Then you can test new protection scheme without real-world implementation, saving time and cost. And lastly, provide a safe environment for operator training. The drawback is costly to purchase and maintain. Next is complex and challenging to learn. Then sensitivity to input parameter may affect result. So overall, simulation tools are valuable for studying harmonic impact on power system protection, but it's essential to consider their benefits and limitations before use. Next, for the data collection, the method we use is field measurement, lab test, and simulation. For the field measurement, we use sensor monitor real harmonic, accurate but time consuming. For the lab test, is in a controlled environment, study protection scheme, not always like the actual system. And the data analysis identify trends, understand impacts, and find effective mitigation. For the reliable data, you need to properly design collection for trustworthy result. For the statistically analysis, you need to use appropriate method for insights, and to utilize the result, we need to improve protection, understanding, and suggest mitigation. For the experimental setup, the purpose is to study harmonics effect on protection scheme. The component is power source, harmonic generator, protection scheme, and measurement equipment. For the accurate result, we need to careful planning with real power system equipment. For the precise measurement, reliable equipment to detect harmonic currents and voltage need to be used. So for the control environment, we need to avoid interference, maintain stable condition, analysis, understanding harmonic impact on protection method. So to use the result, identify variable mitigation technique for power protection. For the measurement technique, we can use current and voltage transformer. It is simple and affordable, and measure waveform and a few harmonics. Next is spectrum analyzer. It is more expensive, but it can cover wider frequency range and suitable for higher frequency. And lastly, harmonic distortion meter. It is the cheapest. It can measure total harmonic distortion, but not individual harmonic. We need to choose the method based on the study needs. To ensure the reliability, we need to carefully select the approach, calibrate the equipment, and avoid the interference. Then, next, for the analysis technique, we need to use a filter. It is remove harmonics from the system, allowing the fundamental frequency. Secondly, is load balancing. It can reduce harmonics by balancing load. And lastly, selecting less harmonic sensitive load. It opt for load that are less affected by harmonics. Lastly, for the performance evaluation, the benefits we got is improved performance. It can identify strength and areas for improvement. And then motivation, we need to find feedback and recognition to to drive better performance, and lastly, informed decision. It can help with compensation and promotion. For the challenge we got is subjectivity. The opinion may lead to bias, time consuming, and resistance. I think that's all from me. Thank you.
Hello, my name is SHAHRUL NIZAM bin SABRIE, matric number DE 2098. I'm going to present about the results and discussion. First of all, there are 4 types of harmonics. The first one is harmonics categorized into the voltage and current harmonics, the odd and even, also known as integer and non-integer harmonics, voltage harmonics that is caused by device altering voltage waveform, and also current harmonics that is result from the non-linear loads. And then next one is the impact of the harmonics. The first one is the overcurrent protection, which fault stripping due to the inaccurate fault current measurements. The second one is differential protection. Imbalance will lead to misinterpretation of the internal faults. The third one is distance protection, which will cause errors in fault distance calculation from distorted waveforms. And also the last one is earth fault protection, which will fault the tripping, especially with the third harmonic. And then the next part is the managing and mitigating harmonics. For harmonic filters, they have two types, which is the passive and active for reducing the harmonics, and also the standard and guidelines are following the adherence to the IEE 519 for the limits and the mitigation. For power quality monitoring, the continuous monitoring is used for quick detection, and for proper equipment design, harmonics tolerant device to reduce the emissions. And for the new and improvement strategies, first strategy is to filter installation, which will be used passive and active filters to target specific harmonics. And then selective harmonic elimination. It is a technique to cancel out the problem in the harmonics. And the next one is upgraded protection relays, which will higher the sampling rates for more accurate measurements. And then the harmonic current limits, which setting the restrictions on harmonic current levels. And then power quality monitoring is to do real-time monitoring to identify the issues that will arise. And then the load distribution is to balancing the non-linear loads across the systems. And then the system design and equipment selection is to properly selecting harmonics tolerant equipment so it won't bring a lot of problems. And then the first one is education and training, giving awareness for the workers for more effective harmonics management. So for the result discussion, effectively managing harmonics is crucial for power system stability and reliability. Implementing the appropriate mitigation strategies, monitoring and equipment selection will ensure the protection schemes, accuracy and overall power system efficiency are much more higher. The regular evaluation and continuous improvement are essential for the harmonics management to succeed. That is all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So I will conclude this presentation. For harmonics, unwanted frequency that can distort the sinusoidal waveform of the power supply, leading to various issues in power system protection. Harmonics introduce voltage and current distortion, which can affect the overall power quality. This distortion in turn interferes with sensitive electronic equipment, communication system and control device, causing malfunction, data errors and operational issues. It is therefore crucial to implement power quality monitoring and corrective measures to maintain acceptable power quality levels. By understanding the behavior of harmonics and their implication on power system components, engineers can design and implement effective protection strategies to ensure reliable and efficient power system operation. So that's all from me. Thank you.